So we are moving forward with solving equations, and there are properties that allow us to solve these equations, and we just do it automatically. But you're going to have to justify your solving. You're going to have to identify what property allowed you to get to that next step. And you're going to create proofs, algebraic proofs. So in order to do that, we need to understand and really know our properties. So let's start with properties of equality. So here are our four basic ones. This is what you've been doing since you learned how to solve equations. So the addition property of equality says if A equals B, so if you've got an equation, left side equals right side, you can add the same thing to both sides and keep your equation true. So that's why we say what you do to one side, you must do to the other. Same thing with subtraction. If A equals B, then you can subtract C from both sides. That allows you to bring one thing from one side to the other. That also works with multiplication. And it works with division. So while you're copying these down, if you want to pause it and then listen to what I have to say, that's fine as well. But your properties of equality is what's helping you isolate your variable. So when we do the inverse operation and bring something over, these properties are why we do it to both sides. Remember, it's like a scale. We got to keep it balanced. Okay? So if you need more time, go ahead and pause now to finish copying these down. And then we're going to move on to some other properties, and some of them are new for you. So make sure that you're writing them down and you understand. If you don't understand one of them, leave a comment below the video so that we can target those tomorrow in class. So we have the reflexive property. Think about what reflexive sounds like. It sounds like reflection, right? Well, when you look in the mirror, you're looking at yourself. It's you. If you have a blue shirt on, you're going to have a blue shirt on in the mirror. So it's what you are. A equals A. That makes sense. Then you have the symmetric property. Remember in elementary school, the line of symmetry? Well, that's what this is. A equals B, then B has to equal A. Okay? Now, these two are going to come in more in geometry, but you'll see them a couple times in algebra. Your transitive property. So bear with me on this one. It's saying if A equals B and B also equals C, therefore A equals C. So this one kind of confuses people when you read it this way, but we will get into tomorrow this actually like in a problem and it'll make more sense. But if I told you that you and I have the same shirt on and you and Johnny have the same shirt on, that also means that myself and Johnny have the same shirt on. So that kind of is where this is coming in. Then you have the distributive property. That one, we did a whole topic on it in section 1. You've been doing this in 6th grade. Whatever's on the outside, you multiply by everything on the inside. Okay? Now, this property, you've been doing this. You've been doing substitution throughout things. We actually just did it in our last video. We're proving a solution to be true. But what it's saying is if A equals B, so X equals 2 or Y equals 5, then I can plug that in and replace it anywhere in an expression. Look what I have here with stars. Always use parentheses when you're substituting in a value. So when you're replacing something with what it equals, you need to put parentheses around what you're putting in. Okay, so let's go and see if we can identify these properties more in person. So you got two equations. They're separated by the word and. From the first one to the second one, there's a property that happened. I want you to identify that. So right now, go ahead and look at the 2 while I read them, and you can work ahead. Always pause if you want to, and see if you were right. So here I have x minus 5 equals 3x plus 7. But then on the second one, I have x minus 5 plus 5 and 3x plus 7 plus 5. Everyone should be calling out the addition property. I'm adding the same thing to both sides. So let's go look at my next one. 2 times x plus 4 equals 14 minus 6x. But now I have 2x plus 8. That should look very familiar to all of us. That's our distributive property. Then I have x equals 3x plus 12. My second equation is x minus 3x equals 3x minus 3x plus 12. Whatever I'm saying on both sides, that pretty much is what's happening. You're right, subtraction property. I'm subtracting 3x from both sides. And then I come down here. I have 2x plus 8 plus 6x equals 14. Now I have 2x plus 6x plus 8 equals 14. I wonder what property that is. All I did was move the 6 and the 8. I had movement. That's your commutative. You're right. I didn't go over it in this video, but that's something you need to realize. If it's something we have done this year, or if it's something that has been done in the past, you need to know it. You need to remember it. Math is like a pyramid. It builds. There's a reason why we teach things in a certain order, because you need one topic before the other. So your properties, as you add properties, the other ones aren't going away. Okay, so why do we need to know these? Who cares? Well, take a look at these things. What you see coming up here, you see statements, and then basically what you're seeing is equations solved. You're like, yeah, I do that all the time. But look at the reasons, the right-hand side. Those are justifications. What you're seeing here on this page, these are algebraic proofs. So when you go from the given, which is your equation, and you're asked to solve it, you have to explain what property you use to get to that next step. So I'm going to show you how this really works. So when we solve equations, we've kind of drilled in you, all right? We subtract 3 from both sides, right? And then I write 2x equals 12. Then I'm going to divide both sides by 2, and I'm going to get x equals 6. So this is the work we normally do. However, when you're solving an algebraic proof, notice what got taken out. Okay, you're missing the minus 3 minus 3. So that right there, that's the property that got you to this. So when you justify and you write your reason next to it, you would write subtraction property of equality. Then this you don't see, right? Because dividing by 2 is what got you to this. So the property is the division property of equality. That's what got you to that next step. Okay? What you're doing is you are justifying. You're proving or showing it, and you're explaining why it happened, what allowed you to do it. You have to justify. So let's go justify each step. So from this given, I had 2 times x minus 3 equals 18. Now I have 2x minus 6. What did I do to go from the first row to the second? I distributed. I used the distributive property. Now, to go from the second to the third, notice what's different. I got rid of that minus 6. So how would I do that? You're right. I would add 6 to both sides. So by adding 6 to both sides, I use the addition property of equality. Then finally, from this third row to the fourth, what would I do to get it to 12? I'd have to, my work and the steps I would be doing would be divide by 2, correct? So that is your, okay, so now you see how to justify and why we do the steps we do. So now it's your turn. I want you to pause and try each step on their own. If you actually have to do the property to figure it out, that's okay too. But you need to give a reason for each line. Okay, let's look and see what we would do first. So based off these statements, they chose the first step. You could have done something else first, but they did something. So you have to go with what they broke down. So what they did was they got rid of the dividing by 2 on the left. How do you do that? Well, you'd multiply by 2. If you do it on the left, you do it on the right. So what's the reason that got them to step 2? Right? I hope you wrote multiplication property of equality. Now on this third row, our reason's going to be, what did we do in row 2 to get us to row 3? Good. If you said distributive property, you're right. Now, before I go on, if you did this, which you should have, this is how we're going to figure out what you don't get. Go ahead and cross out your answer, but then write in the correct answer. Okay? All right, now we're on row 4 for our reason. What did we do? Obviously, the 15 got moved. Well, how do I move that? Subtraction property of equality. And last, I got rid of that 5 with the A. So what did I do? I divide both sides by 5. That then is the division property of equality. Okay? So I have one more thing for us to practice. Now, this table is something you could see on EOC. So this is a little bit more in depth. Notice they don't necessarily give you step by step. They just want to know which properties would you use to solve. So this first row is easy. I just got to get rid of the 2. So that would be the multiplication or division. Okay? So on this next step, I know I have to bring over my 7 and bring over my 2. So think about what properties that would be. Right, addition or subtraction. See how they're in one column? As well as multiplication or division. Okay, so now that you see what we're doing, I want you to try the rest of these on your own. Pause the video now and try and identify which property you would use in order to solve these. Okay, so I would, on this one, there's only one property, you divide, okay? Now on this next one, x minus 3, I need to bring that 3 over, so I'm doing the addition property. So now I have something new compared to all the other 4 we've done. First, I'm gonna have to distribute. Then I'm going to have to bring over and divide. So I'm using all 3 properties. Okay? Again, this one should be easy. We're just subtracting. Now on this one, be careful. Yeah, you're going to add 8, but then you're left with a negative x. Remember, x has to be completely by itself. So how do I make x positive? It's actually division property, okay? Now this one has a lot involved, this last one. I'm gonna distribute. I'm also going to combine like terms but I'm gonna do that by moving things around. Then I'm going to add or subtract, and then I'm going to divide. So if you understood this content, be sure to click like. If there's something you did not get, especially on that last one, I'm assuming some people might be struggling, and that's okay. Put that in your summary or comment below, and we can go over that tomorrow in class.